Grace is here. Jackson's here. Is Jessica here? Jessica. Nope. Absent. Molly? No. Cindy? Yes. So that's section 903. We have 3 participants from here. Emerson, absent. Alex? Nope. Hi, Angie, I saw you. Alex is not here. Lex is here. Emma is here. Ashlyn is here. Jack is here. Angie is here. Jennifer is here. Chris, I do not see Crystal. You're welcome. Charlie? Nope. Chloe? Nope. Levy's here. So that is 3, this is 7, 10 participants. The number matches. Okay, this is the plan for today, everybody. You know, we have 2 sections, right? One section is also enrolled in the essential part of the class, which meets 2:30, right? 2:30 to 3:20. So today we are scheduled to review for exam 1. We have 54 questions in the review, and it's gonna take longer than 80 minutes to finish those questions. I don't really want to rush. So here the plan is I'm going to combine the 2 sessions in one here, all right? So we are going to meet here from 1 o'clock to 3:10. Let me write it down. Today's plan. Review. For exam 1 from 1 p.m. to 3:10 p.m. here. So it means we don't like log out and log back in another session. I will take attendance for the essential class the end of the session around 3:10. Am I clear? Do you see what I'm trying to say here? Hello? Okay, so this class is a combination of 2 sections. Part of you only enrolled in the QR session. The rest of the students, they enrolled in both QR and essential. Yes, so we won't have our normal essential. Yes, you won't have to log out and log back in another course shop. You're gonna stay here until 3:10. All right. The essential part is optional for the students who only enrolled in QR, but it's mandatory for the students who enrolled in both, because I'm gonna take attendance. Does that sound good? So when you need to rewatch the recording, you only need to go to QR course shell and find the video. The one video would have the whole review. We don't have to cut off. Also, I don't think 80 minutes is enough for finish the review. So the QR students, they will not have the whole, review. So I want to combine those. Is okay? Yeah. Anybody? What do you think? Agree or disagree? Perfect. Awesome. So today here in this session, we are going to keep reviewing, keep practicing in the review until 310. Until 310. Okay, so let's get started. And the one thing I want to point out is this green flag in front of exam 1. I think I mentioned this before. This green flag needs to disappear in order for you to have the access to take the exam. How do you make the green flag disappear? You have to pass the review with 75% or above. Very important. Make sure you have the review passed as early as possible. Practice one time probably is not enough. You want to practice more times, a few more times, and then go to take your exam. So let's start a review. So did we do something already? Seems it says continue. Oh, we already did it. We already did this many questions. Seems we did. Okay. Anyway, we want to combine the class. So let's continue number 13. This is number 13, right? This is number 14 actually. You have not completed all parts of this question. Are you sure want to leave this question? No. Okay, let's do number 14. Write the statement below in symbolic form and construct a truth table. Then indicate under what conditions, if any, the compound statement is true. Let P represent the statement x is less than 6, and Q represent the statement x is bigger than 8. Okay, let's see. We have 8 answer choices. We have 8 answer choices here. I'm going to process this problem on a note. At the same time, please read the problems thoroughly. So we have P. P represents x is less than 6. We have Q. Q here represents x is bigger than 8. Then the negation of P would represent x is bigger than or equal to 6. And the negation of Q would represent x is less than or equal to 8. Right? And our compound statement is this one. Let's read the sentence. It is true that x is less than 6 and x is bigger than 8, comma, but, comma indicates a grouping symbol, right? And but indicates conjunction. So the structure of this compound statement is a conjunction. The sentence in front of the but or the comma is the first piece. The part behind but, that is the second piece. Let's look at the first piece. I'm going to highlight it in yellow. The first piece in a conjunction is yellow. It says it is true that x is less than 6 and x is bigger than 8. A and D here is also a conjunction, right? Conjunction of x is less than 6, which is P, x is bigger than 8, which is Q. So the first piece of the conjunction compound statement is P and Q. And the second piece of conjunction, I'm going to represent using the blue color. It says not x is bigger than or equal to 6 or x is less than or equal to 8. Not not x is bigger than or equal to 6. So we negate but not, it is true that, but not true that. Okay, I got it. So this not actually negate the whole disjunction. X is bigger than or equal to 6 is not P. X is less than or equal to 8 is not Q. Alright, basically the sentence says, it is true that X is less than 6 and X is bigger than 8, but it is not true. It is not true. X is bigger than or equal to 6, or X is less than or equal to 8. So that's the structure. That's the symbolic form of the compound statement. It's very complicated, right? Yeah, let's see what we have here. The big structure of the statement is a conjunction. So if it's not a conjunction, it's going to be out. A is out because it's a disjunction here. C is out for the same reason, disjunction. E is out because also is a disjunction, right? So we get rid of 3 of them already. This one is out, the same thing. And the other 4, they are conjunction. The first piece of the conjunction is P and Q. P and Q. So D is out because here is P or Q. And then we have 3 left. The second P is a negation. Negation of not P or not Q. Not P or not Q. This one is AND, so G is out. This one is AND, so H is out. So we only have F. Okay, let's compare. My form is the same with F, right? P and Q is in the parentheses. Take the conjunction of that with the negation of another parentheses. In the parentheses, we have a negation of P or negation of Q. So we should choose F. Second part is to complete the truth table. We have a lot of columns. Column 3 is the negation of P. When P is T, negation of P is F. When P is T, negation of P is F. When P is F, negation of P is T. When P is F, negation of P is T. So column 1 and column 3 should have opposite truth values. Now negation of Q. Negation of Q should have the opposite truth values from the truth value of Q. So look at the column 2. When Q is T, negation is F. When Q is F, negation is T. When Q is T, negation is F. When Q is F, negation is T, right? So column 2 and column 4, they should have opposite truth values. Next, P and Q, conjunction. P and Q, the two pieces in the conjunction are the first 2 columns. So if you have a piece of strip of paper, it's always good that you cover these 2 columns, then you don't make a mistake, right? Yeah, we only need to look at the first 2 columns for this conjunction. The sentence we need to memorize about conjunction is the only case a conjunction is true is when both pieces are true. TT, okay, so this is true. All other 3 cases, we do not have both true, so they are F. Next column is the disjunction of not P and not Q. It's a disjunction. The 2 pieces are column 3 and column 4. So if you have strip paper, you can cover, like hide the first 2 columns, right? So knowing this disjunction, the 2 pieces in this disjunction are column 3 and column 4. What's the sentence we need to memorize about disjunction? For disjunction to be false, both 2 pieces must be false, right? Then let's look at the column 3 and the column 4. Do we have FF? Yeah, we have one case in which the column 3 and the column 4 are both F. That's the first case. So FF, and the disjunction is F. All other 3 cases, they are T. T, 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 right? And the column after that is a negation. Okay, do you have any questions? How are they t? What are they? What is they? Because disjunction is low maintenance, for a disjunction to be true, at least one is true would be enough. The only case a disjunction is false is when both pieces are false, right? The two pieces are
So are
go
you
ahead.
saying that there has to at least be one that is different and the rest are the same?
One different, the rest of the same.
Because you said those two F's right there equals an F, and then the rest of them are T's.
Yeah, that's what I said. So because for a disjunction to be false, both two pieces have to be false, right? In order for this disjunction to be false, negation of P need to be false and the negation of Q needs to be false. Only when both two pieces are false, the disjunction is false. All other three cases, there are at least one is true. If a disjunction has at least one piece is true, then the disjunction is true.
So if one is true, then the rest of them are true?
It's not the rest of them. Is if it's one is true, okay.
Mm-hmm.
So let me give you, how about this? Let's say disjunction, okay? First piece is star, second piece is triangle. The two pieces in the disjunction star and triangle. If at least one of star triangle is true, the disjunction is true. Basically, star or triangle. Oh no, you're about to be signed out. If I have to restart my computer, Hello, I'm back. I'm sorry. The computer is reinforcing. I mean, is forcing a update. Are you guys still there? And it's still recording. Okay. So when you watch the video, it's gonna be one part of it. It's just black for a little bit. All right. So I was explaining the problem to Emma, right? So this is disjunction. Disjunction means or. All right. So P or Q is true means PQ at least one is true. P or Q is true basically means at least one of PQ is true, right? At least is okay to be for both to be true, but at least one is true. So in order for a disjunction to be true, it really only takes at least one is true. Does that make more sense, Emma? I have to log in everything. Okay, awesome. Let's go back. Here. Assignments. Review. Continue. Where were we? We were on number 13, right? Oh, it has to force me to do on number 15 now. Okay, but it doesn't let me go back 14. If I try to go back 14, it doesn't let me. Let me try. Alert, you cannot navigate to a different question. So let's just keep going. Number 15. Number 15 is about sets. Is about two concepts, equivalent and equal. We have two sets. I'm going to write the two sets in the raster method, then we can understand the two sets better. Set A contains elements that are natural numbers. This notation means natural number set. And the natural numbers is bigger than or equal to 12 and less than 14. So the elements in A include 12, 13, and that's it, only two, right? 14 is not an element because it says strictly less than 14. And the set B contains all the natural numbers bigger than 8 and less than or equal to 10, right here. So we start from 9 and 10. Okay, set B also contains two elements. So as you can see, the cardinal number of A and the cardinal number of B are equal, both equal to 2. For that reason, A, B are equivalent. That's the definition for equivalent. Two sets are equivalent if they have the same cardinality. However, the two sets are not equal because they do not have exactly the same elements, right? A has 12, 13, B has 9, 10, very different. So we should choose, for the first part, we should choose D. The sets are equivalent because n of A equals n of B. N of A means the cardinal number of A, n of B represents the cardinality of B. So that is the first part. Second part, Are the sets equal? They are not equal, okay? Two sets are equal is very high standard. They have to be exactly the same. They are not equal because A does not contain the exact same elements as B. That's the reason, okay? They are not equal. So this question is about equivalent and equal. You just need to know the two concepts. Next, determine whether this notation, both or neither, can be placed in the blank to make the statement true. We have two sets here on each side of the blank. We can tell the set on the left has three elements, SCV, and the set on the right has four elements, SCVM. I can quickly draw a Venn diagram to show the relationship. So this is SCV and this is M. So this is set A, this is set B. Then this is A, set A, this is set B. Do you agree? Do you agree? A is a subset. A is a proper subset of B. Do you agree? A is a proper subset of B. This involves, this is related to the definition of proper subset. In order to be a proper subset, the set of A has to be completed inside the set of B. And the set of A is smaller, set of B is bigger. B is bigger. It has more than one more element than A, right? So this is a proper subset. And it is also subset, okay? If A is a proper subset of B, then A is also a proper, if A is a proper subset of B, then A is also a subset of B. Just like if 2 is strictly less than 3, then 2 is no more than 3. Both would work. Both would work, okay? So what should we choose here? We should choose what? Tell me, A, B, C, or D? Determine whether, can we put, what symbol we can put here in the blank to make the statement true? Both, perfect, awesome. We choose both. Next, question number 17. Find the cardinal number for the given set. This is a very simple problem. It only concerns the definition of a cardinal number. All you need to know is the definition of a cardinal number of a set. The cardinal number of a set is the number of elements in a set. Set A has 1, 2, 3, 4, 4 elements. So the cardinal number of the set is 4. Done. Do not lose a point from this type of problem. Very simple. Question number 18 is to ask if the set on the left a subset of the set on the right. It does not concern proper subset. It's only about subset or not subset. In order for this set to be a subset of this one, all the elements in this one has to be also elements in this one. So 2 is in the set, right? 3, 5. What do you think? What elements in the second set on the right? How do we understand the dot, dot, dot here? It doesn't give us all the elements, but you should be able to see the pattern, right? This set contains all the natural numbers from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, 2, 3, 5 are also elements in this set. So we should choose this symbol, right? This set is a subset of this one. Traveling at an average rate of between 40 and 50 miles per hour for 5 to 6 hours, Select the best estimate for the distance traveled. Firstly, we need to know distance equals speed times time. It's a very basic formula that I think is kind of like common sense. Everybody should know. Distance equals speed times time. If you drive 60 miles per hour and you drive 2 hours, then you use 60 times 2, 120. That's the distance you drive over the 2 hours. Okay, so we don't know exact the speed, exact the hours. So we have to estimate. Let me get a calculator. The speed, it says the speed is 40 miles per hour, between 40 miles per hour and 50 miles per hour. Now I'm going to take the number in the middle. 40, 50, in the middle we have 45. So use the middle or the average of the speed is make more sense, right? 45 miles per hour multiplied by the estimation of the time. The time says 526 hours. Then the middle is 5.5 hours. 5.5. And the result is 247.5. And then look at the ABCD. Look at the ABCD. C is too much, C is out. D is too little, D is out. And let's look at A and B. Which one is closer to 247.5? I think this one is closer. A is closer, right? Yeah, so we choose A. That's how to. Question number 20. Determine the truth value for the statement when P is false, Q is false, and R is true. The statement is given in a symbolic form. Q implies parentheses P and R. We're going to work on the problem in a note. P is false. Q is false. R is true. It is given by the problem. The problem tells us those. Yeah, you don't have to ask why. Where do you get that? I got from the question. It says P is false, Q is false, R is true. Based on those information, we need to determine the truth value for Q implies P and R. So this is a conditional, right? It is conditional. What's the sentence that I need you to memorize regarding a conditional statement? There's only one case in which a conditional is false. That is when the antecedent is true, but the consequent is false, right? And the antecedent of this condition is Q, and Q is F. So now we know the antecedent is F. What do you think? Is it true or false? You are right. Trust friends forever. Only when we have a trusted friends, we have forever. Only when the antecedent is true, but the consequence is false, the conditional is false. But now we already know the consequent, we already know the antecedent is false. What do you think? So the conditional, do we need to figure out what's the truth value for the consequent? We don't need to. We don't even need to bother to do that. Because the antecedent is not T, is F. So we definitely will not have trust friends. We will not have trust. We already know we do not have trust friends. So we won't have forever. What do you think? Do you agree with T? Does that make sense logically? We do not need to figure out the truth value for the consequent. We already know we will not have trust friends, right? Because the antecedent is F. Okay, awesome. So it's T. It is T. Next, question number 21. Identify the reasoning process, induction or deduction. In the following example, explain your answer. The course policy states that work turned in late will be marked down a grade. I turned in my report day late, so it was marked down from B to C. So what do you think? The policy applies to all people, right? Since the policy applies to all people, it also applies you. So the number of cases going down from all to one specific person is decreasing. Since it's decreasing, it's deductive reasoning. This is an example of deductive reasoning. The specific conclusion, your or my report get a 1 degree down, 1 grade down. The report is marked down from B to C, was arrived at from one or more general statement. So that's, I believe you see this a similar problem in your homework. None of the questions in the review, none of the questions in the actual test would surprise you because those questions are from the same pool with your questions in the homework assignments. You should have seen those questions many times. Question number 22. Use the standard form of valid arguments to draw a valid conclusion from the given premises. Okay, so we have an argument here. The two premises are given. We need to come up with a conclusion to make the argument valid. Let's see the first premise. It says, if some families need homes, then Habitat for Humanities may help. The second premise says, Habitat for Humanities did not help. Therefore, okay, this is going to be a contrapositive reasoning. This is going to be a contrapositive reasoning. Do you guys remember what is contrapositive reasoning? It's right here. If I let P be let P be families need homes, Q as the habitat for humanities, H for H may help, right? Then negation of P would be some families do not need homes. Families do not need home. Now Q, negation of Q would be H for H may not help, not helping, or not help, right? Yeah, do not worry about the grammar or the time. So let's see. The first premise says if some families need homes, then H for H may help. So that means P implies Q. That's the first premise. Second premise says habitat for humanities did not help. So that is not Q, right? So if we use the contrapositive reasoning, we should draw the conclusion, not P. P implies Q. Then not Q should imply not P. The conclusion should be not P. Not P is families do not need homes. So let's see which one says that. Families, choose the correct conclusion below. Some families do not need families. Some families need homes. No families need a home. Okay, the negation, some families. So this one, kind of like a quantified. Yeah, let me adjust this. Some families need a home. So the negation would be no families. No families need a home, right? Okay, no families need a home. So the negation of P would be no families need a home. So that's what we do. We basically used the counterpositive reasoning. How do you know how to do this problem? When you are familiar enough, with this table, the 4 popular reasonings and the 4 popular fallacies, and you will see it. You will see it. Okay, next. Question number 23. We are given a quantified statement. We need to find out A, express the quantified statement in an equivalent way. That is, in a way that has exactly the same meaning. B is to find the negation of the quantified statement. The negation should begin with all, some, or no. Okay, so let's do that. Do you guys remember the 4 types of negation, quantified statement? First type, all A are B. Second type, no A are B. Third type, some A are B. Fourth type, some A are not B. All right. So the negate, what we have, the quantified statement says all integers are numbers. That is the first type. This is the first type. Okay, first type. So the equivalent. Remember the equivalent for all A are B? The equivalent for all A are B is there isn't one A that is not B. There isn't one A that is not B. All A are B has the same meaning with there isn't one A that is not B. So the equivalent way to say all integers are numbers would be there isn't one integer that is not a number. All right, so this is the equivalent way, same meaning. Let's see which one is the same with what we have just come up with. There is no integer that is not numbers. Okay, so I would choose this one. There are no integers that are not numbers. Yeah, same meaning, same meaning. The wording a little bit different, but same meaning. What about negation? Do you guys remember those two are negation of each other? Those two are negation of each other. So the negation of all A are B is some A are not B. So the negation of all integers are numbers is some integers are not numbers. Some integers are not numbers. Some integers are not numbers. This one, right? So we had a similar practice in a class, finding the equivalent for a quantified statement, finding the negation for a quantified statement. So that's this problem. Question number 24. Determine truth value for the statement below. When P is false, Q is true, and R is false. Okay. It is given that the question tells us P is F, false, Q is true, R is false. All right? P is false, Q is true, R is false. And then we need to determine the truth value for not P or Q and not R. Let me color them. This is a disjunction. The first piece is blue. Second piece, I'm going to use purple. How about that? Right? P is F. Okay, P is F, so the blue is going to be T, agree? P is F, so the blue is going to be T, going to be true, because the blue is the negation of P, right? If P is F, then the negation of P is true. And you know what? We do not have to worry about the purple. We don't have to bother to figure out the truth value for the purple part. We know that disjunction is going to be true because at least the one piece is true would make the disjunction to be true. Emma, do you see that? This is a disjunction. It has two pieces, blue and purple. We already know the blue is true, and that's enough to know the disjunction is true, because at least one is true would make the disjunction to be true. You see that? Do you see that? Any response? Yeah, right? So we don't have to worry about the purple part. We already know is true. The statement is true. Okay, this one is about union. Union, okay? Union means or. Or here means at least one. So we are including the elements at least belong to one of A, B. So A has 1, 2, 4, 5. B has 3, 5, 7. Okay, let's go through the values, the elements. 1, yes, because 1 belongs to A. 2, yes, 2 belongs to A. 3, yes, 3 belongs to B. 4, yes, belong to A. 5, yes, belong to both, right? Of course, belong to the union. 6 is no. 6 does not belong to either, right? So 6 cannot be an element in a union. But 7, yes. And that's it. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 7. Question number 26. Determine whether the statement is true or false. The statement says 19 is in the set. In other words, 19 is an element of the set. Is it not obvious? It's right here, right? You see that? 19. True, because 19 is a natural number greater than or equal to 19 and less than or equal to 32. And this part is the description of the set right here. Elements in this set are natural numbers bigger than or equal to 19 and less than or equal to 32. Okay, next. And let me know if you have any questions. You're welcome to type the question anytime. Question number 27. Use a truth table to determine whether the symbolic form of the argument below is valid or invalid. We would have to use a truth table. My guess right now is valid, but you know, we'd better use a truth table. And it has 3 simple statements, so it's going to take a little bit of time. All right, it's going to take a little bit of time. Firstly, I'm going to translate the argument as a conditional statement. The antecedent of the conditional statement is P implies Q implies R and P and Q. All right. So the first premise, P implies R. Conjunction, second premise, P and Q. Together would lead to the conclusion, which is R or Q. So that is the conditional statement we are going to figure out, right? 1, 2, 3, 4, 5, 6, 7, 8. This time I draw the number of rows. I draw the rows first in case I make it too big. We have 3 simple statements, PQR. The last column is going to be the target conditional statement. All right, that's going to be our target. Let's just draw a star here. This is the star. And I want this one to be the consequent. I want this one to be the consequent, R or Q. And this one would be the antecedent. The antecedent is P implies R and P and Q. And I want this to be P implies R, and this is P and Q. All right, so those should be enough. We have column 1, column 2, column 3, column 4, column 5, column 6, column 7, column 8. Do you guys remember how do we give the 8 cases for the first 3 columns? PQR. For PQ, we have TT, TF, FT, FF. Do the same thing. TT, TF, FT, FF. And R has T, 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 F, 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 F. So that's how do we find the 8 cases for the truth values of PQR. And let's see how we get a column 4 taken care of. Column 4 is a conditional. Column 4 is conditional. Column 4 has P as antecedent, R as the consequent. So we are looking at column 1, 3. Column 1, antecedent. Column 3, consequent. For a conditional to be false, antecedent must be true, consequent is false. So we are looking for trust friends. Do we have trust friends? TT no, TT no, FT no, FT no, TF, okay, trust friends forever. Okay, right here. This is case 1, case 2, case 3, case 4, case 5, case 6, case 7, case 8. Case 5 has trust friends in the yellow, right? Trust friends forever. Case 6 is the same, trust friends forever. And that's it. All other 6 cases, we do not have trust friends. So they are T, 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 T. Column 5 is a conjunction. Column 5 is a conjunction of P and Q. So column 1 and column 2. All right. Column 5 is a conjunction of column 1 and column 2. So now we should look at the first 2 columns. Ignore R. Ignore column 3. So for a conjunction to be true, both 2 pieces must be true. Case 1, both are true. Case 2, not. Case 3, not. Case 4, not. Case 5, yes, both true, so true. All other cases, they are not, so F. All right, so next column is number 6. Column 6 is a conjunction. The 2 pieces in the conjunction are column 4 and column 5. The 2 columns next to it, all right? So we're going to have column 4 and column 5. Conjunction together give column 6. So we have this column 4 and column 5. Again, for a conjunction to be true, both 2 pieces must be true. We have TT, T. No, not TT, not TT, not TT, not TT. Okay, so that's the only case. Case 1 is the only case both column 4 and column 5 are true, right? All other cases I do not see them. Okay, so all other cases F, 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 F. Now we do column 7. Column 7 is a disjunction. Column 7 is disjunction. The two pieces are R and Q, or Q and R, so column 2 and column 3. Number 7, column 7 is the disjunction of column 2 and column 3. For a disjunction to be false, both two pieces must be false. Let's see, do we have cases both of the two yellows are false? Case 6, F. Case 8, F. You are looking at the column 2 and the column 3, the yellow part, okay, guys? Do you see both 2F? Do you see both 2F, Q and R? Case 6 and case 8, right? Those are the only two cases. Both pieces are F. Very good. I hope you guys are with me. Means all other cases they are T, 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 right? Okay, finally we can do the last column, column 8. Column 8 has antecedent column 6 and a consequent column 7. Yeah, the order is already there. We like the order. It's the ideal order. Remember, conditional statement is false only when the antecedent is true but consequence is false, right? So do we have a trust friends forever? Trust friends, no. Trust friends, trust, we do not have. What do you think? We do not have trust friends, right? So they are all T. This is a tautology. When the statement, conditional statement is a tautology, all T, that means the argument is valid. It's the same with what I guessed. You know, how did I guess? The second premise tells us both PQ are true. The second premise tells us P is true and Q is true. And Q is true, the guaranteeing this disjunction to be true. So that's how do I know it's true. So it's valid. But we use the truth table proved it is true, right? So it's valid. Next, determine if the set finite or infinite. How do we understand the set? This set has natural numbers bigger than or equal to 1300, all right? So this set contains natural numbers, and those natural numbers have to be bigger than or equal to 1300. To rewrite a set in the raster notation, this set contains elements 1300 bigger than or equal to, right? Starting from 1300 has to be natural number. 1301, 1302, 1303, and so on and so on and so on and so on forever. Since it's forever continuing, is infinite. Next, question number 30. With aging, body fat increases and muscle mass declines. The line graph shows the percent body fat in adult females and males as they age from 25 to 75-year-old. Use the information to complete part A through part C. Part A. Find an estimate for the percent body fat in 45-year-old females. Okay, this is about female. So ignore the blue graph. Only look at the red graph. It's asking us to estimate the percent. Percent is the Y value, vertical scale. When the female is 45-year-old, 45 is here. And this is between 36 and 38. This is 36. You should be able to see my very huge, large arrowhead, right? So this is 36, this is 40. So between 36 and 40, we have 38. And the body fat percent, the corresponding 45-year-old female, is between 36 and 38. So I would say 37 is a good estimation. That's part A. Part B. At what age does the percent body fat in females, so still the red curve, reach a maximum? Okay, this is the maximum. What age? 55-year-old, right? 55-year-old reach the maximum body fat percentage. And what's the percent body fat for that age? So 55-year-old, the percent body fat reach the maximum, and the maximum equals 40%, as you can see here, right? 55-year-old peak, and it's 40%. 40%. Part C. At what age do females have 34% body fat? 34. This is 32. This is 36. So 34 should be in between right here, right? And at what age? At what age? The age is 25-year-old, right? Yeah, when a female 25-year-old, the body fat is 34%. 25-year-old. And that's it. Next, I'll let you to do that. Determine if this set, -909, a subset of the one on the right. It has -9, -7, 7, 9. Is this set a subset of this one? What's the definition for subset? Not a subset. You're right. Thank you, Ashlyn. I want to make sure everybody's with me. You guys are with me, right? It's not a subset. Very good. Okay, very good. Thank you for responding. Next. Question number 31. Use a truth table to determine if the following symbolic form of an argument is valid or invalid. Okay, we don't have to use a truth table, guys. This is a fallacy. Oh no, hold on. This is definitely invalid. I would say this is the misuse of direct reasoning. Let me get the note from, this should be 3.8. Let me show you the table. Oh, sorry, 3.7, my bad, 3.7. 3.7 right here. It doesn't have the misuse of direct reasoning, but it's kind of like that meaning. Okay, we'll use the truth table, quickly get it done. It's not very complicated. By feeling, you can feel is gonna be invalid, right? Because P would cause not Q to occur. But it doesn't say the negation of P would cause the same thing. So I would say it's invalid. But let's translate. This is conditional with antecedent, the conjunction of the first piece per first premise and the second premise. And the consequent is the condition is the conclusion, not Q. All right. So this one is going to be not a very big table. 1, 2, 3, 4. PQ, TT, TF, FT, FF. So the target would be our statement, and the one in front of it is going to be the consequent, and this one is going to be the antecedent. So P implies Q and not P, right? So this would be antecedent. P implies not Q. Oh, I copied it wrong. P implies not Q. And not P. We need a not P, not Q. Not P, not Q. We need a P implies not Q. P implies not Q. All right. Let's fill in the blanks. Column 1, column 2, column 3, column 4, column 5, column 6, column 7, column 8. Case 1, case 2, case 3, case 4. You can time yourself to see how long it takes you to use this method. Column 3, negation of P, F, F, T, T. Look at the column 1 and column 3. Make sure they have different truth values. Column 4 is negation of Q, F, T, F, T. Column 2 and column 4 should have opposite truth values, right? Okay. Column 5. Column 5 is a conditional with P as antecedent. So column 1 antecedent. Consequent is not Q. Consequent is 4. All right. So column 1 is antecedent. Column 4 is the consequent. I'm going to highlight them in yellow. This is antecedent. This is the consequent. And we are looking for trust friends. Well, we do have trust friends. The first case, trust friends forever. Second case is not. Third case, no. Fourth case, no. We have one trust friends forever. So the other three, T, T, T. Right? So that's column 5. That is column 5. Column 6. Column 6 is a conjunction. The two pieces in the conjunction are column 5 and column 3. Let me highlight them in yellow. Column 3 is not P. One piece of the conjunction. Column 5 is P implies not Q. That's another piece. All right. For a conjunction to be true, both have to be true. Look at the two yellow columns. Do we have both T? The case 3 and case 4, right? Both T. T, 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 T. And the other two cases, F, F. And the consequent is not Q. Not Q is the same with column 4. So you just need to copy column 4. Column 4. So we have F, T, F, T. So column 8 is a conditional. Column 8 has a consequent right in front of it and antecedent right in front of the consequent. So that's the ideal order. Antecedent, column 6, consequent, column 7, and follow with the conditional, right? Do we have a trust friends? Trust friends, yes. Forever, right? F, sorry, trust friends forever. Trust friends forever. All other cases are T. Well, even there's only one F, that means the statement is not tautology. Is not always true. So this is invalid, okay? I would say this is misuse of a direct reasoning. Is invalid, okay? Next. Question number 32. Question number 32. Let's see if we can just understand right here. The problem is the table. I don't have enough. I can't show you all the information. Okay. P represents prices peaked in 2000. This is 2000. Prices peaked in 2000. Q represents prices remain steady from 1985 through 1990. 1985 through 1990. The price did not remain steady, right? It's actually going up. So Q is false. R prices were less than $3.75 per gallon in 1995. 1995. The price is $3.50. Yeah, it is less than $3.75. Okay, so what do we need to figure out here? Write the symbolic statement, not P and Q. Okay, so it has nothing to do with R. This is not P and Q in words. Then use the information to determine the truth value of the statement. This is a conjunction. Conjunction. So you are expecting to see and. The two pieces in a conjunction, not P, Q. P says prices peaked. So not P would be prices did not peak in 2000, right? Okay, so which one? So which one? It's really hard to show you the whole thing. Okay, guys, please answer the question. A or B or C or D? Which one translates this? Not P and Q. Not P and Q. C? Okay, let's look at it. C says prices did not peak and the prices remain steady. Yeah, I agree. It is C. Awesome. Awesome, very good. And can we determine the truth value for this statement? It's a conjunction, by the way. For a conjunction to be true, both have to be true. What do you think? First piece says the price did not peak in 2000. We choose this one, right? We choose that one, C. Prices did not peak. That is false. It didn't peak. So we don't have to go further. We know this is going to be false. All right? It's going to be very false. And that's it. A lot of information. But as I said, you should have already seen this problem multiple times. Okay, next. Question 34. No, 33. Identify a pattern in a given list of numbers, then use the pattern to find the next number. More than one pattern might exist, so it is possible that there's more than one correct answer. What pattern do you see? 5, 12, 19, 26, 33. You tell me, guys. The distance is 7, right? Yeah, increased by 7. Awesome, very good. Perfect. Exactly. Thank you, Ashlyn. Thank you, Jack. 40. Question number 35. Okay, what a diagram to determine the validity. Draw the graph. Premise 1. Okay, so since multiple of A, multiple of 4, it doesn't really feel very comfortable. I'm going to use A to represent a set of multiples of 8. B represents a set of multiples of 4. Okay, so the first premise says all multiples of 8 are multiples of 4. So it is all A are B. That's what the first premise says. Second premise says number 9. This is number 9. Hold on. Yeah, number 9 is not multiple of 8, means it's not in A. Conclusion, number 9 is not a multiple of 4, so not in B. So once we use AB to represent the two sets, that's how do we translate the argument. And then we can maybe draw the diagram more easily, right? All A are B, so this is A, this is B, all A are B, so A is inside B. Number 9 is not in A. Number 9 is not in A. This is number 9. Can we draw the conclusion number 9 is not in B? We can't. Because my diagram shows the opposite. Yeah, it's possible 9 is outside B, but it's also possible 9 is outside, inside B, but outside A. Right? So this diagram would be a counterexample to show the argument is invalid. Hope you see it already. It's invalid. Next. 35. Use the Venn diagram to represent the set B prime. Okay. Let me show you what is B prime, all right? B prime means the complement of B. B prime means complement of B. Let me use the color to shade the region that represent. Okay, this probably the page is too much stuff. I'm gonna close that and start a new note. Probably this page has too much stuff. I'm gonna start a new one. Okay. B prime means not B or complement of B. It includes elements in the universal set, but not in the set B. This region represents B prime, okay? As you can see, there are 4 elements in B prime, 2, 4, 23, 26. This is clear, very clear. So we have 2, 4, 2, 4, 23, 26. There's 26 over here. Done. Question number 35. Oh, give a little bit of time. Okay, so question number 36, truth table. Column 3, Q and P, conjunction. For a conjunction to be true, both two pieces have to be true, right? Don't forget it's capital letter. And then the other three cases, they are not both true, so F, F, F. Q or P, disjunction. For the disjunction to be false, both two pieces have to be false. And all other three cases, T. The last column is a conditional. Antecedent is this column. Consequent is this column. We do have the ideal order. Antecedent, consequent, conditional. Do we have a trusted friends? We do not have a trusted friends, so they are all T. And done. This is tautology, all right? It is a tautology. Bear with me, the connection is not the best, so it seems takes a little bit of time to move on to the next question. I don't know how much you have been using the tutoring services. You are not recommended to use tutoring services for the review. You need to do the review by yourself. This one is also about truth tables. Negation of Q. So look at the column 2. When Q is T, this is F. When Q is F, this is T. When Q is T, this is F. When Q is F, this is T. So make sure column 2 and column 3, they have opposite truth values. Oh, miss one here. Yeah, it's always good to double check. They have opposite truth values. Next column is a conjunction of not Q and P. Not Q is here, P is here. So column 1 and column 3, conjunction. For a conjunction to be true, both have to be true. But we do have case 2, T, T, so this is T, right? Again, we are looking at column 1 and column 3. Case 2, they are both T. All other three cases, not, so F. The last column is the disjunction of this column and this column. It's a disjunction of the two columns next to it, all right? For disjunction to be false, both have to be false, so this one is F. And all other, this one also both F, right? So this is also F. And this is a T, and this is T. Next. Question number 38. For the given set, first calculate the number of subsets and then find the number of a proper subset. Remember, guys, the formula? If set A has n elements, then the number of subsets is 2 to the power of n. The number of a proper subset is 1 less than 2 to the power of n. All right? So let's see how many elements in this set. 1, 2, 3, 4. So the number of a subset is 2 to the power of 4th. 2 to the power of 4th is 2 times 2 times 2 times 2, which is 16. Number of a proper subset is 1 less than that, 15. And done. It's about a formula. You need to understand and memorize the formula. Next. Okay, so let's see what's going on here. I think we might talk about this problem before. In the Venn diagram, we have 4 regions, right? Let's figure out what does the 4 region represent. Region 1 is country A disagree. Region 2, country A people agree. Region 3, country B people agree. Region 4, country B people disagree. All right, so that's the 4 regions. And part A is to find how many country B agree. Country B agree. So we are looking for the cardinal number of region 3, right? Region 3. It says here, the results of the survey shows that 228 people agreed with the statement. So that means there are 228 people in this circle. In other words, the cardinal number of 2 and the cardinal number of 3 together is 228. Yeah, the result of the survey showed 228 people agreed. And 81 people from country A agreed. So region 2 is country A people agree. So region 2 has 81 people. All right. So if region 2 has 81 people, region 2, region 3 together has 228 people, then region 3 should have 228 minus 81, which is 147. All right? Yeah, 147. So region 3 has 147 people. 147. So we choose region 3. Here, region 3. And how many people there? Oh, here. Region 3 in the who agree with the statement. B, country B agree. So that is 147. We got it. And we have another part. So part A, we choose region 3. And the number of elements in region 3. And part B. Okay, we have another part. Let me copy paste. Part B is to find how many people in country B who disagree. Okay, country B disagree. So part B is to find the cardinal number for region 4. All right, region 4. And we know there are 626 adults from country A. 626. Okay, that means they are 626 people in that circle. And in region 3, we just found out in region 3 we have 147. So 626 add 147, that is 773. So means together in this region, we have 700, this region, we have 773 people. And the universal set has 1180 people, and that is given. Use that to minus 773, the 70, let me double check, 80, 11, okay. 407 people in region 4. 407. Yeah, I remember these problems definitely from a homework assignment. This one, use the Venn diagram which shows the cardinality of each region to answer the question below. Okay, this is how do we know? Those numbers are not elements, they are cardinalities. It says so, which shows the cardinality of each region. How many elements belong to A but not C? Okay, which region is belong to A but not C. Belong to A but not C. This region represents the set of elements belong to A but not C, right? And as you can see, we have 7 elements here, 3 elements in there. So in the shaded region, I just shaded in pink. In that region, we have 10 elements. Next, question number 41, sorry. What do you think about this one? Do you remember what this notation means, guys? What does this notation mean? The big circle with a slash across the circle. What does that mean? Correct. Thank you, Ashlyn. It's the famous empty set. I say famous because I want you to know that. All right. Is the empty set a proper subset of the set? A subset of the set? We should choose both, okay? The empty set is a proper subset of this non-empty set. So it's also a subset. This one is both, okay? Hope you see it. If not, text in the chat. Question number 42. Region 1. So this is region 1, region 2, region 3. It says region 2 has 8 elements, right? So region 1, do you notice that region 1 is region A minus region 2? And the circle A has 34 elements, is given. Minus the elements, number of elements in region 2, which is 8. We have 26. Okay, yeah. And so we type 26 here. Next, ask region 3, okay? Region 3 is region B minus region 2. Region B has how many elements? Region B has 32. 32 minus the elements, number of elements in region 2, which is 8, and that gives us 24. Region 3 has 24 elements. Region 4, okay, let's figure out how many elements in region 4. Region 4 is the white region, right? So we know now region 1 has 26, region 2 has 8, region 3 has 24 elements. Add those 3 cardinalities together, we have 58. Yeah. And subtract the 58 elements from the universal cardinality, which is 69. 69 minus 58, we have 11. 11 elements in region 4. 11 elements in region 4. And that's it. This one is a good question. Not very easy, but it's not challenging. It's very good, pretty good question. Question number 43. Find a counterexample to show that the following statement is false. We want to show is false, okay? So you are not selecting anything that can serve as evidence to support the statement. I would say C is out because it says a number is multiplied by itself. 3 times 5 is not a number multiplied by itself. D is out because it says a number multiplied by itself, and here's adding. And we can only do A or B. A is supporting the statement, okay? If a number is multiplied by itself, the result is even, 16 is even. So this is an evidence, show this is true, is supporting it, this one. We are looking for a counter example, has to be the second one. 5 multiplied by itself, the result is 25. It is not even, it is odd. Okay, hope you see it. Next. Write a compound statement in symbolic form. Let the letters assigned to the simple statement represent that are not negated. This is a very important condition, all right? The letters cannot be negated. If commas do not appear in common English statements, use the dominance of connectives to show grouping symbols, parentheses in symbolic statements. So here, let's figure it out, okay? Let's figure it out. P says, I like my teacher. This is P. Q says, the course is interesting. That's Q. R says, I miss class. So this R, right? PQR is given. And the sentence here says, if I like my teacher or the course is interesting, then I do not miss class. This is conditional for sure. If blah, blah, then blah, blah. So it's conditional. The antecedent would be the part following if, right? So I can color it in blue. I like my teacher or the course is interesting. So that is the antecedent. The antecedent has a or, so it's going to be a disjunction. Disjunction of I like my teacher P, course is interesting, Q, P or Q. So P or Q is the antecedent. The consequent is the part following then. So the purple here is the consequent. Consequent says I do not miss class. I miss class is R. I do not miss class is negation of R. So this is supposed to be the symbolic form of the statement. Let's enter in the cell. P or Q implies not R. Yeah, let me double check. I like my teacher. If I like my teacher P or course interesting Q, then I do not miss class. I miss class R. Okay, that's correct. Next. Number 45. Choose which reasoning process is shown in the following example. Explain your answer. Okay, you do this one, guys. You do this one. Deduction or induction? And which one? A, B, C, D. Which one correctly explained the reasoning? Yes, I agree. It's B. Perfect. Inductive. From specific to general. from 2,098 people to all patients, Yeah, even 2,000 is a very big number, but there are specific examples. It's inductive because a general conclusion is drawn based on specific observations. Awesome. Next. Use a Euler diagram. Okay, so let's draw the diagram. All snakes have forked tongues. No pigeons are snakes. Therefore, no pigeons have forked tongues. I saw 3 sets. Let A be the set of all snakes. Let B be the set of all things with forked tongues. C represents the set of all pigeons. All right. First premise: all snakes are things with forked tongues, so all A are B. Premise 2: no pigeons are snakes, so no C are A. No pigeons are snakes, so no C are A. Conclusion: therefore, no pigeons, so no C are B. Okay, let's figure it out. Let's draw the graph now. All A are B, right? All A are B. No C are A. A have to be disjoint. No C are A means the circle of A and the circle of C cannot touch or overlap. So they have to be disjoint. Can we draw the conclusion? No C are B. Can we draw the conclusion? C and B are also disjoint. My diagram shows the otherwise, right? C and B could overlap. C and B could overlap. So no C are B. No C are B. Is not always true. It's not always true. All right, so it's invalid. Do you see that, guys? Yeah. You agree it's invalid because we found the counterexample. Invalid. In a symbolic form. P, you are human. Q, you have wings. Being human is necessary for not having wings. Okay, necessary. P implies Q can be translated as if P then Q. Also can be translated as P is sufficient for Q. Also can be translated as Q is necessary for P. Okay, we need to use this one. This one says the consequent is necessary for the antecedent. All right, consequent is necessary for the antecedent. You need to memorize this. Consequent is necessary for the antecedent. So it says being human is necessary for not having wings. Being human is necessary for that. So being human is a consequent. Being human is a consequent. Is right here. Consequent is necessary for antecedent. Not having wings, not having wings is the antecedent. Having wings is Q, so negation of Q is the antecedent. Do you agree, guys? Yeah, you need to remember consequent is necessary for antecedent. Okay, antecedent. So do you agree what I wrote? Okay, very good. Next. 48. How many elements, what's the cardinality in here? Please answer in the chat. Awesome, very good. You guys are great. Do not fall for the trick. They want you to enter 8, but no, it's just one element. One element. And this one, express the given set using the raster method. The set of natural numbers less than 8. This one is easy. The smallest natural number is 1. 1, 2, 3, 4, 5, 6, 7. Not including 8, because natural numbers are less than 8. So up to 7. Okay, 1, 2, 3, 4, 5, 6, 7. That's it. Next. Complement. Complement. A complement includes elements in U but not in A, right? So this means not A. The sets A complement include all the elements in U but not in A. So we are going to cross out the elements in A from the universal set. A has S, so cross out S. A has W, so cross out W. A has X, so cross out X. A has Y, so cross out Y. So cross out the 4 elements in A. The rest of the elements TUV. Let me remember, TUV would be in A prime. TUV. TUV. That's it. All right. Next. Question number 51. Determine if the set is an empty set. The elements in the set are numbers less than 2 and at the same time bigger than 8. What do you think, guys? Empty or not empty? Do we have numbers less than 2 at the same time bigger than 8? Yes, it's empty set. Perfect. You guys are great. Thank you. Is the empty set. So it is, the set is empty. Okay. Next, 52. Estimation. We have an expression with 3 numbers added together. Round each number to the nearest integer. Okay, this one should be easy. Integer. 9.74 round up to $10. 117 rounded down to $1. So now you have $10, right? 18.36 rounded down to 18. So you have 10 here. You have 10 here. You have 1 here. That's 11. Did I misspoke something? Okay, so this is 10. This is 1. That is 11. 11 add on top of 18 is 29. So the estimation is 29. Okay. Yeah, so 11, 18, so 29. And the actual value, actual sum, we can use a calculator. We add $9.74 with $1.17 with $18.36. And the actual value is 29.27. 29.27. Right? And it is reasoning, and the estimation is a little bit lower. It is reasonable. The estimation seems a little bit lower than the actual, right? It's pretty practical. Suppose that is on your receipt. You bought 3 items from the store. You can quickly estimate how much you should pay, right? You should pay around $29. And you end up with paying 29.27. So it's very good estimation. Next, 53. Determine whether or not the sentence is a statement. The moon is made of green cheese. You tell me, A, B, C, D. The moon is made of green cheese. A, B, C, D. You choose A? Okay, let's see what is A. Yes, because the sentence can be either true or false, but not both simultaneously. Correct. Obviously, this is a lie, right? That means a false statement. You admit it's a false statement is a statement, right? It tells a lie. It is false. Very good. 54. Refer to the following statement to answer part A through C. The professor is intelligent and an overachiever, or not an overachiever. Write the statement in symbolic form. Assign letters to simple statements that are not negated. This is very important. For that, because of that information, we are going to get rid of A, because A let Q be professor, not overachiever. So it tells you use a letter to represent simple statements that are not negated. So A is out. For the same reason, D is out. Now we only have B or C, right? Yeah, take notes. We only have B, C left. And the statement says blah, 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 comma, or. I don't even have to read it. I know it's going to be a disjunction, right? So we have B or C left. Has to be C. I use the method of elimination. And then you can double check if the details match. P is the professor is intelligent. The professor is intelligent and overachiever. Or not overachiever. Yeah, everything match. But we got this done by using method of elimination, right? Every information matters. It specifically tells you the letters have to represent statements that are not negated. Yeah, for that, we can let A and D go away, right? Yeah, B, C. C is the correct one. You have not completed all parts of the question. Are you sure? No, I'm not sure. So we have, sorry about that. We have more parts. Table here. Column 3, P and Q. For the conjunction to be true, both have to be true. All other three cases are not both true, so F. Now Q, negation of Q. When Q is T, this is F. When Q is F, this is T. When Q is T, F. When Q is F, is T. So double check, always important. Column 2, column 4 should always have opposite elements. I mean, truth values. The last column is a disjunction. The two pieces in the disjunction is this column and this column. We have the ideal order. For the disjunction to be false, both have to be false. So here we have both false. Both false, so it's false. All other three cases, T. Still not done yet. Okay, so by looking at the last column, we know which one is true. Is it true when, okay, so let's see if this one is true. Is it true when hold on. There are no conditions. So A is not correct. B is not correct. C says the statement is true when P is true, Q is false. When P is true, Q is false. The statement is true. Okay, that match. So that one is the correct answer. It will not let me, for some reason, it will not let me go back. Yeah, because of the setting. It won't let me go back here. So we will not have 100%, okay? We will miss 2 questions. I apologize for that. So we miss this one 14 and 13, right? We missed 2 questions. All other questions seems, oh, the last one. Let's see what happened to the last one. The statement is true when P is true and Q is false. The statement is true when P is true and Q is false. The statement is true when P is true. This is a typo. This is a mistake, okay? It's not my mistake. The correct answer should be C. The correct answer is C. The statement is true when P is true and Q is false. When P is true and Q is false, the statement is true. There's nothing wrong with that. Instead, this one is not true, okay? I think you won't have something like that in the exam. Yeah, the correct answer is supposed to be C. I wasn't making a mistake. This is C is correct. All right, C is correct. P is true or Q is false. P is true or Q is false. P is true. Oh, P is true or Q is false. So as long as it's not P is false and Q is true. Okay, my bad. D is better. But C is correct as well. But okay. I think D is a better answer. P is true or this one a bit tricky. So P is true or let's find the negation. Let's find the negation of this part. Negation of P is true or Q is false. The negation is P is F and Q is T. All right? And that is the case 3 when P is false and Q is T. So this is F. Oh, this is a little tricky, this one is D. So it's the opposite. Yeah, you use actually there's a dimorpho. So the negation of A or B is A prime and B prime. I don't know if this helps you. So A can be seen as A here is P is true. B here is Q is false. So the negation of A or B is A prime and B prime. A prime would be P is false. B prime is Q is true, right? So you're gonna only when this and this is F. All other cases T. Yeah, this one actually takes more than what we have learned. This one actually takes more than what we have learned. But it's just one part of a question. And now we should be able to go back 13 and 14. This is an easy one. Circle, square, triangle. Okay, circle, square, triangle. Circle, square, triangle. So circle. Yeah, that's one easy, right? And number 14, choose tables. It doesn't really give me the option to do a similar problem. Yeah, this one, there's only one case is true. That is when both PQ are true. I can translate this one. Write a statement below in symbolic form and construct a truth table, then indicate under what conditions, if any, the compound statement is true. Let P represent, okay, P here is X is less than, we actually was doing this problem, and then I had to restart the computer, right? Yeah, so P is X is less than 6. Q here is X is bigger than A. So negation of P is X bigger than or equal to 6. Negation of Q is X less than or equal to A. And the statement says it is true that X is less than A and X is bigger than 8. But, so this means a conjunction, all right? It is true that X is less than 6 and X is bigger than A. So P and Q. But it's not true that X is bigger than or equal to 6 or X is less than or equal to 8. So not P or not Q. I think we mentioned this part earlier. And then the computer restarted itself. Yeah, and then you fill in the truth table. Anybody missed the roll calling? Anybody missed the roll calling, guys? For the QR session today? Charlie, okay. Yes, Ashlyn, what's the question? Charlie, do you remember which section you are at? Maybe this one? No, you're the other section. Anybody else missed the roll calling? Oh, Alex. From now on, I'm not going to respond to emails telling me I was late. I'll try to take attendance twice. Okay, I'm trying to take attendance twice, the beginning and the end. Because every day I receive so many emails just telling me I'm late, can you fix my attendance? I start to feel tired about it. So I'm not going to respond those emails anymore. So let's see where which section Alex is. You can see it's very troublesome if you are late and I have to fix this every time. Alex, that was the other one. This one. Anybody else before I close that? Oh, it's okay, but just let you know and other students know I'm not gonna do that anymore. And now I'm gonna take the attendance for the essential. Essential. It's this one. Today. Let's see, is Emerson here? I believe not. Alex is here. Is Lexi still here? Yeah. Is Emma here? Ashlyn? Is Ashlyn here? Yes, perfect. Jack is here. Is Angie still here? Yep. Jennifer, is Jennifer here? Jennifer, she left, right? Oh, no. Jennifer's here. My bad. Jennifer is here. Crystal, didn't see her. Crystal is not here. And Charlie is here. Chloe, not here. Levi is here. Okay. So almost all the participants are from Essential, in fact. All right, I remember someone's asking a question. Ashlyn, so next week, will we have normal class meetings or will we use the class time to take our exam? That's a very good question that our syllabus would be able to answer us. Let's look at the syllabus. Okay, how about let me just tell you. Yes, we have normal classes. We have normal classes, and we meet every Monday and Wednesday. We meet every Monday and Wednesday afternoon. You go to the testing center at your convenience exam. I do take attendance for the classes. Did I answer your question? Ashlyn? All right, guys. So that's everything for today. Please practice as much as possible. Pass the review as early as you can. So we will meet. Yes. I'll see you on Monday at 1. Have a good have a good weekend.
Thank you.
You're welcome. Have a good one. You're welcome. Bye bye.